Okay, everybody, welcome to this afternoon's session on 3D model making. So we're going to be working quite hands-on, doing some 3D modeling work within this wonderful software called Blender. So it's similar to softwares such as Cinema 4D and Maya, only it's completely open source, and it's free, and it's available on all operating systems. So I'd recommend anybody that wishes to follow along throughout this tutorial, and it may be quite dull otherwise, to download a copy of Blender. So if you go to blender.org and go to this one here, Get Blender 2.8 Beta. This should work on most laptops, but if it doesn't work on yours, then go for the older version, Blender 2.79. But I'd recommend everybody starts by downloading 2.8 Beta. So my name's Mark Ransley. I work at Ravensbourne with Carl and Jazz. I originally studied maths and music, and then got master's degrees in maths and computer science. I'm just finishing my PhD in mechanical engineering, and I've also already done a postdoc in computer vision. This is the kind of stuff I was doing in my PhD on these sort of 3D printable chainmail fabrics, and using physics simulators such as the one in Blender in order to kind of investigate their properties as a material. Another thing that I don't often bring up in academic talks is that for many years I've been producing designs and renders and technical drawings for paint jobs, for private jets, for someone I'm related to who paints them. And actually, all of this work is done in Blender as well. So I found that across all these different streams of my professional life, some of them are things that are, they start as hobbies and then turn into almost full-blown careers. They all seem to involve Blender work. So I'm pretty much just trying to stress to you the usefulness, the utility of this software. So let's talk about 3D model making. What would augmented reality be without it? It would be pretty dull. It would be lots of text floating in midair. It's the 3D models that really bring it to life and make it interesting. It's a medium that lends itself better to 3D models than any that's come before it, I would claim, because of the way that you're able to move around the real world and see these fantastical objects embedded within it. So 3D model making is very, very important for augmented reality. I think that if progress hadn't been made in this stuff, but it had been in, say, the computer vision and tracking technologies, then it would still be a really horrible area to work in. It's only because it builds on decades of incredible work in 3D modeling and animation that this is such an exciting form to work with right now. So that's why we're going to learn some of that today. So yes, I'll be talking about Blender, especially Blender 2.8, but you will be able to actually still do pretty much everything that we're going to do within an older version of Blender. I'm going to talk about the fundamentals of 3D modeling, i.e. how you do things to a mesh, what a 3D structure is, how things are done to it, how one can be changed from one shape into another, this kind of thing. Then we're going to go into character rigging and animation, which is how you kind of start to really bring these things to life. Shading and texturing, where you go from having just a very flat, plain, uniform-looking 3D mesh to something that appears a lot more realistic or interesting. And then finally exporting it into Unity and building it into an augmented reality app. So you should have the entire workflow covered within this session. And throughout, we'll be doing a case study that I've put together on building an animated robot hand. And you can get all of the files that we use along the way, different stages, from that link. OK, so yeah, we'll be building this animated robot hand, then rigging it up with a kind of internalized skeleton model. Attaching it to that model, then animating the skeletal model to animate the robot hand, and then we'll be applying some nice-looking materials onto it, lighting it up, and then moving it into Unity. And you are all encouraged to follow along with me here. So about Blender, I already mentioned a couple of these. It's been free and it's been open source for a long, long time. It's very mature software at this point, but it's also very much on the cutting edge. In many ways, it's ahead of industry-leading software, commercial software, I should say. It's multi-platform. It has a phenomenal real-time rendering engine, which I'm going to show you in the next slide, I believe. Which is fantastic because previously to produce good quality renders, you would have to sit back and let it spend a very long time churning out your image, but not anymore. It also has a massive community of users who've been using it for a long time, a lot of them. So there's any issue you can think of, there's some forum post that deconstructs it brilliantly, and there's some fantastic video tutorials up on pretty much everything now. And loads of add-ons. So all the things that we're going to do in this session could probably be simplified through an existing add-on that someone will have made. It's just that it's wise when you start out to kind of work at the most basic level. Many, many good features within Blender, such as modeling meshes, which is what we'll be doing today. There's modeling another type of 3D structure called NURBS. It also features UV mapping tools, which is the way that you kind of apply a flat 2D image onto a 3D object, which is the method through which pretty much all 3D models of things start to look realistic. Somebody's mapped a 2D texture, normally a photo, onto it. Blender's very, very good at that. And this is the kind of stuff that Unity is just not built for whatsoever. It also has a really good timeline editor where you can add keyframes. You can adjust properties according to the keyframes and the way that it blends from one keyframe value to another. Blender can do all of that stuff for every single property within this, this 3D environment. It's phenomenal. It can also do these physically based rendering materials, which is a kind of state-of-the-art technique for producing really fast and really realistic details and images. You can also do image compositing, so stuff that you'd normally have to go out into Photoshop, for example. You can actually do it all within Blender. Ray tracing, which is a very kind of advanced technique for modeling light if you want something that's ultra realistic. Camera tracking, so you can integrate your 3D world into existing footage that's been shot. So essentially augmented reality in the kind of old school VFX way. Rigid and soft body physics simulations. This is a different way of animating things where you kind of describe how they react to the laws of physics, and then you hit simulate, and things just play out according to a physics simulation, rather than you having to kind of manually animate where each thing's going. Two different schools of thought for animation. They both have their virtues. It also handles particles and fluids, so you can produce images or videos or even interactive content with those kinds of things. Interactive virtual liquids, that sort of thing. Blender is capable of that. And it's also got a Python scripting interface, which means that everything that I'm going to show you, everything you can do within Blender, you can actually write into a Python script. So you can automate all of the clicking and dragging and everything, and end up producing some far more complex things, or just repeating things a lot more without it being so tedious. So it's amazing, Blender. Also, yes, combined with Unity, it becomes extremely powerful. As I say, Unity cannot do things like mesh editing or UV mapping. It's not great for timeline-based animation, I've found. Lots of, and the ray tracing thing is just sort of rumored as a future feature. However, Blender doesn't do real time. It's designed for kind of making a model or producing an animation, and then you have a video that you can watch or an image afterwards. Whereas Unity is a game engine. It's designed to run things in real time. So if you use Blender to construct objects, make them look good, set up a scene, it's far easier to do that than in Unity, then move that over into Unity and compile it into some sort of real-time experience, which can be a game or an AR app, all sorts of things, then I claim that you could actually cover the entire workflow using just these two bits of software. Possibly you might choose to, bring in Photoshop or Illustrator, but I do think that Blender could actually replace both of those if you were really committed. So here's some examples of things that you can do within this 2.8 version of Blender with the real-time component. The one on the left is a video that I made last week just to kind of test it out, and you can see that it has very sort of realistic lighting effects. You can handle reflective surfaces. You can kind of add camera wobble and shake. Yeah, a lot of really, really nice things. All the trees in the background and the gravel and the paving stones are all modeled. Yeah, that's one example. Another thing, the geometry, that is actually a monument from the former Yugoslavian region. They're called Spomeniks, and I've found myself quite fascinated with them lately. So I took one as a case study and saw how, what could be done with modeling it in Blender. Really just to sort of test out what this latest version can do in regards to lighting and photorealism, that kind of thing. And then the next video I'm going to show you is from one of the developers of this latest version of Blender, where he's produced this incredible scene with some sort of bionic alien getting pumped full of things in a lab with loads of machinery around him. And you can see that this is all being done in real time. That's what I think is so cool about this. The photorealism that previously you'd have to, sit there for 10 minutes waiting for such an image to actually come out is all happening in real time. It's very, very snappy and responsive. There's lots of videos like this where people just show a time lapse of their creative process within Blender, and it's a great way to sort of, just see where you can go with this stuff. How to go from primitive geometric shapes to something incredibly complex and realistic or fantastical. So I'd recommend watching a few of those videos if you're really into it, because obviously I can only scratch the surface of what's possible with this software today. You could totally do an entire 3-year course on it and still be wanting more. I've put together here a cheat sheet, though, of all of the keyboard shortcuts that you would find useful for the things that we're doing within this tutorial. So yeah, either get a photo or get the slides from the Drive folder. Yeah, just there for your reference, really, because there are an awful lot of keyboard shortcuts out there in Blender. So, going through the entire list of them to find the one you want isn't going to be that productive. But all the ones that you're likely to want, I think, are within this table here. So now we're going to move into a demo part of the session. I am going to now talk through the Blender user interface from scratch. So I've just fired it up. This is the 2.8 version. If you've got 2.7 version, it will be similar, but a kind of a lighter aesthetic to the UI. So using the middle wheel, the mouse wheel, or 2 fingers on a trackpad, you're able to move around in 3D space, as I'm doing now. Actually, let me just turn on. There's this add-on here, which should now tell you in the bottom left corner what buttons and mouse buttons I'm working with. That may prove helpful. So yes, by using the trackpad or the middle button on your mouse, by holding that down and then moving around, you can navigate around in 3D space. Anyone that's used 3D software before, that's normally how they do it. You can also zoom in and out through doing the kind of spreading motion on a trackpad, or through using the middle wheel on a mouse. You can click around. You can select objects with the left mouse button. That's new to 2.8. It used to be the right one. And if you click into empty space, then suddenly you're selecting nothing. It's all kind of intuitive, but worth explaining. There are some other objects around here. We've got a cube. We've also got a light way up over here. So I can select that, and also a camera. If you press the A key, that selects everything. And if you press Alt-A on the latest version, it deselects everything. Or you could just click into empty space. A lot of the things that you're going to see in here have multiple ways of achieving the same end result. But that's part of the joy of working with this software for a long time. So a few other useful shortcuts. So then if you select everything and press the X key, that allows you to delete everything out of the scene, which you can do by clicking or pressing Enter. So now that's empty. Great. Okay. You can also add objects if you go up here to the top toolbar here. Well, it's sort of the top toolbar of this window. And you click Add a mesh, and then add a cube. And that gives us a cube right in the middle again. So we're almost back to where we started from before we deleted everything. Some other useful controls here. If you press the G key, the selected object is now movable. We can move the object around, so that's the G key. And then using your mouse, or you can also type values in, numerical values to move things. And you can also either accept that by clicking left, as we just did, or you can cancel that movement by clicking with the right key, and it will just go back to where it was. So that's the G key for moving objects around. Let's move that right back to the 0 point. You can also, when you have an object selected, within this panel you can see its location, and you can change it just using a numerical slider like so. Another really useful thing for moving objects that we'll be making use of in the demo here is constraining movement to a certain axis. So if you press the G key for moving it, and you just want to move it along the x-axis, then you press the X key, and it's now locked to that axis. And similarly with Y, and also with Z. I kind of glossed over it because it probably wasn't worth mentioning, but yeah, as it's a 3D environment, you have x-axis, y-axis, and also a z-axis. A z-axis doesn't have a grid, it's just x and y. You also have the axis represented up here at the top, so you can see x going this way in red, y in green, and z in blue. And if I move around with the middle wheel, or two fingers on a trackpad, then you can see the axes moving along both on the grid and also up at the top here. So that's just the view. The object's position and rotation still remain fixed. We're just changing our view around it. So as I said earlier, you can move the object with the G key, but you can rotate it with the R key. So right now it's just rotating it based on the angle that we're looking at it from. But you can, just like with the movement, you can constrain it so you just rotate around the x-axis by then pressing the X key. So if you select an object and you hit R and then X, then you get this constrained movement around that axis. And similarly with Y and Z. So G for movement, R for rotation, and the other kind of Euclidean distortion that you can apply to things, transformation, sorry, is scaling, which is done with the S key. So if you tap S, you can then drag or you can type a value, and you will scale the object. And similarly, of course, you can confine it to just the x-axis. So if we want an object to suddenly be twice as long in that direction, then we tap SX2, and it's scaled it twice along the x-axis. So there's some fundamentals of 3D modeling just for kind of transforming objects. Another really useful one for setting up a scene is duplicate. Duplicating objects is very useful, which is done with Shift-D. You see that at the bottom of the screen. Shift-D duplicates something, and you can then move it around. And as before, if you're happy with where it is, you can also type values to say where it should be moved. You can constrain it so the new object goes along just a particular axis. And when you're happy, you can click or you can right-click, and it will just jump back, so it's duplicated in the exact same space as the original. So there's different ways of manipulating objects. I'm now going to talk to you about different ways of viewing within Blender. So we know that you can change the perspective you're viewing from. You can also change the way that things are rendered. So if you go up to the top here of this 3D viewport, the 3D viewport is this main window that we see that kind of runs from the far side right over to here, and then down almost to the bottom of the screen. That's the 3D viewport. And in time, we'll come to what all the other viewports are doing as well. Let's just get rid of that toolbar. So over here, at the very top right corner of the 3D viewport, you can see the different shading modes, different rendering modes. Right now, we're on what's called solid mode, and you can see the objects are rendered as solid objects. If you click the one on the left, though, wireframe, now you see that they become kind of invisible. It might be quite hard to see that on the projector screen. I can't tell from here. But that's, yeah, the wireframe mode. It can be really helpful for when you've got a lot of objects all kind of stacked around each other, which we will encounter in a little bit. There's also a different view mode called Look Dev, where it looks similar to the solid one, but it has some other nice features, such as when I click on this box, you can actually see, even though it's obscured by the box on the left, it has highlighted, Blender does highlight the edges of it. It's a kind of selective X-ray view of things. And there's also the rendered mode, which is where things start to look really sweet. They don't right now because we haven't set up any lights or materials, but when we get to that stage, the rendered mode will be quite mind-blowing. So that's the different view modes. Another useful thing, if you want to just view something from the top, you click on the Z button up here in the axes, and now we get a perfect flat view from the top. And you can similarly go to the different sides or front on, all the different views that you could want in terms of just orthographic, straight on, side on views. Can be achieved through clicking this gimbal up at the top here. You can also do it if you go up to the toolbar here and say View, Viewport Top. Or if you've got a big keyboard with that little numeric grid on the side of it, you can go to different views by pressing the numbers on there. So that's working with objects. I'm going to just select the one on the right by clicking it and delete it by pressing X and Enter. And we're just left with this guy. Now we're going to talk about different modes within the 3D viewport. Currently we're in object mode, where you have a pile of objects and you can duplicate objects, you can select different ones, you can transform them. But what if you wanted to edit an object? Well, you select it, and then you move into edit mode by pressing the Tab key. So press the Tab key, and now we're in edit mode. Blender has a bunch of different modes, but if you just tap the Tab key, you switch between object and edit mode. If we had multiple objects and we selected one of them, note that you can only be in edit mode for one object at a time. And you'll see why that's really useful in a moment. So let's go back to the first one, put it into edit mode. And now we're going to talk about the fundamentals of a 3D mesh. So a 3D mesh is made of vertices, which are just points in 3D space, and then edges, which connect them together, and then faces that kind of fill up the vertices and edges. That's probably incredibly obvious to everybody, but it's always worth saying. Now, all of them are currently selected, as you can see by the fact that it's all shaded slightly orange. If I clicked on a particular vertex, then you see the shape actually turns grey, but the one we've selected is just highlighted orange slightly. So I can just left-click and select different ones like that. If I hold Shift and I continue clicking, then we are just adding more vertices to the collection. And similarly, if I hold Shift and I click on one that's already selected, it becomes deselected. So yeah, using Shift to add things to a selection is commonplace in tons of different software. I'm sure you'll have all encountered it before. So we can select vertices like that. Also, we could select edges. If we go up here, and this is contextual. This stuff only appears when we are in edit mode. And you can see which mode you're in through looking at the very top left of the 3D viewport. So we are in edit mode. We were selecting vertices. However, if we go for this one instead, we can now select edges, like so. So that's edge select. I said quite early on that the A key selects everything, and it does the same in edit mode. If I tap A, now all the edges are selected. And if I click into empty space or I press Alt-A, we go to selecting nothing. You could also, for example, select everything with A, and then deselect a few things by using the Shift key. And then there's also face select mode. If we go back up to the top left, pop it into face select mode, and now we can click on individual faces and work with them instead. So that's how you go about editing a mesh. They're the kind of real basics for doing that. Nicely, when you're in edit mode, the same transform keys apply as when you're in object mode. So for movement, we of course have the G key. So now I've selected a face, and I press G, and I can move it around. And of course, if I wish to move it along a certain axis, such as the x-axis, by a certain distance, for example, -2, I just press the X button and type -2, and it moves to exactly there. And you can also, say, rotate an object around the x-axis to kind of give it this like screwing effect, which quickly becomes undone after a certain threshold. And also scaling. So we can have a face selected, and if we tap the S key, we start scaling it inwards. Or we can drag outwards and scale it outwards to create this, it's called a frustum, this kind of 3D trapezoid. So I can then select the bottom face, the other one, I should say, and scale that out a bit. If I wanted to scale it just along the y-axis, I tap S, Y, and now it just scales along the direction of that green y-axis, like so, leaving the others as they were. What we're doing here, I know it looks kind of abstract, but this is actually going to end up being a wrist for our robot hand. So it is actually quite genuine modeling work going on at this point. Oh. And let's scale that out a bit for now. I think that's all right for now, just to demonstrate this kind of trapezoidal shape. You can merge vertices. So if I go into vertex select mode, again, right up at the top left of the screen, in edit mode, and I click on the two vertices I wish to merge, or more, doesn't have to be two. Remember, you can select multiple with the Shift key, and then if I press Alt-M, that's the control for merging vertices, or edges, or faces.
Is it somewhere in the menu as well?
Yes, it is. And it's also in the cheat sheet of keyboard shortcuts that I gave you, because I do think it's a useful one. It should be in there. And then you get this contextual menu appear where you can say where you wish to merge them. You could merge them at the center to get that kind of effect. So that's the essentials of working with 3D objects within Blender. Some other really good things that you can do. You can perform a loop cut where if I select that, it's one of these buttons along the left. Selecting a loop cut, you can then create a kind of hypothetical loop that wraps the entire way around your object. So there's a few different ways of doing that in this one. And when I want that particular one, I click it, as I just did, and then I can drag around to say where that's located. If I click and drag, you can move the cut there, and upon releasing it, you see that it's now gone and created a bunch of additional vertices and edges, and it split the faces in two along those vertices and edges. So to do that, let me show you again. You go over to the left here, and you click Loop Cut. It's that one. It looks like a cube being cut in half by a green band. So you select that, and then click on your object in edit mode where you want to, or the kind of direction and plane that you wish to do the cut in. And then by dragging, you can state where it should be. And that can also be achieved with typing in numbers, of course. So the loop cut's a really, really useful tool for working with meshes. It allows you to start with a really simple mesh that's only got 8 vertices, and very, very quickly increase them, and not just uniformly increase them in places of interest. So we could now, for example, if we went into face select mode, we could select, let's pop that back into select. Go into face select mode, select a face. It's a smaller part than it would have been otherwise because of doing these loop cuts. And then if we were to drag it along the y-axis. You see you can kind of change the complexity of the shape like that. The other really useful mesh editing thing, this is the last one that we'll look at, is extrusion. So extrusion is when you select a face and you don't just move it. Moving it is what we're doing here, where it pulls all of the other neighbors along with it. But if you extrude something, then it kind of copies the face, drags it out, but the neighbors remain in the exact same place. So it's a way of kind of adding an extra bit onto your mesh. That's an extrusion. Oh yes, I didn't say, sorry, that's pressing the E key. So you select a face, and then press the E key to extrude it. And it always extrudes along the direction that the face is pointing in, the normal of the face. But you can also tell it to extrude along a different axis. It's just that it doesn't normally make much sense geometrically to do that. So that's how you go about creating shapes with some real complexity to them through moving objects around, moving vertices and faces and edges, extruding faces in particular. And then you can, say, scale things and rotate things. And that's kind of how 3D modeling is done. There's more advanced tools out there, but they're certainly the most kind of commonplace and the most useful. Oh, yeah. So the next thing I want to talk about is rendering modes. This is, if we went back to the PowerPoint slide, you'd see that it's kind of two different ways of drawing things in 3D. You get the kind of low poly flat shading mode like we're seeing here, which has its own aesthetic virtues, kind of shading things in a way that does look very digital, very old school. But then there's also smooth shading mode like we have here and here. So obviously this line, its smoothness is not on account of being made of billions and billions of vertices, as that just would not work on your phone. The smoothness actually comes from the way that your 3D software is shading it. So you could shade it as a flat object, such as this. In fact, I think that a sphere would probably illustrate this a lot better. So I'm going to just delete this object with X and Enter. I'm back in object mode, by the way. And if I add a sphere through the top left of the 3D viewport, add, mesh, a UV or an icosphere, but they're two different types of sphere. A UV sphere, and let's scale it up a bit. So now we're doing this in flat shading mode, and you can see that it's kind of, it doesn't look real, it doesn't look smooth. You can see the individual faces, which is nice because you could then, work with the individual faces in edit mode, say. However, if we go up to objects in the top left, this is in object mode, and we go down to shade smooth rather than shade flat. So now to shade it smooth, if we go up here into object, up in that top left toolbar again, and we go all the way down to shade smooth, then look at that. What it's done, it's taken each of the kind of vertices and edges, and it's at each point on that sphere, the renderer in your computer actually interpolates between them. So that you get this very, very smooth appearance. You can still see around the edges that it's not made from a perfectly smooth object. You can see the, the flatness that's used to construct it. However, yeah, it does appear in the center to be very, very uniform now. So they're the two different modes of shading things, flat and smooth shading. And there's a ton of other interesting approaches to shading things that we will touch on as well. Some other useful things for navigating around in 3D that I forgot to mention at the start. So we're using the trackpad or two fingers on the trackpad, or clicking and dragging the middle mouse wheel to orbit around in 3D. That's what this kind of movement is called. It's called orbiting around a point. And you can also change the point you're orbiting around by holding the Shift key and then dragging around with the middle mouse wheel, or through rolling the wheel, or using two fingers on the trackpad. So this is just moving, and it's changing the point that we orbit about. But yeah, that's moving around. And then if you release the shift key and continue moving around with the mouse wheel or trackpad, we go back to orbiting. And also, if you hold the control key and you use the wheel, clicked wheel or two fingers on the trackpad, then you're zooming in and out. But you can also achieve that through rolling the wheel or doing this kind of swiping motion with the fingers. So that's ways of moving around in 3D. There was another useful thing that I wanted to cover, which is Boolean operations. So they are... Well, Boolean is also used to describe things in coding in general. You know, you have a Boolean saying whether something's true or false. Boolean is also used in mathematics, in things like set theory, and it's also really fundamental to 3D objects. So what it is, it's the idea of you take two things, then they don't have to be numbers, but you can add and you can subtract them, and you can also do a different type of operation called an intersection. So it turns out you can't just add and subtract numbers. You can do that to a lot of other more abstract concepts as well. Case in point, if we duplicate this sphere using Shift-D, move it along. I'm going to move it along the x-axis and drag it along to, say, here, so that they're kind of intersecting each other like so. You can view it from the side on by clicking that little axis gimbal up at the top right. So we have them intersecting. Currently, it's showing me this little outline of where they are intersecting. But you also, if you went into X-ray mode, remember, also up in the top right corner, if you went into X-ray mode, then you can see exactly how they're overlapping. I should add another nice keyboard shortcut is the Z key. If you press the Z key in a lot of different contexts within the 3D window, you can choose between the wireframe rendering mode or the fully rendered one or the solid one, etc. So that can be easier than moving up to the top right corner. I guess it's down to whatever you prefer. But we're talking about Booleans. So the idea of adding and subtracting one thing from another. A Boolean is a type of, in Blender, a modifier. It's an operation you can apply to an object, normally to a mesh, such as these guys. And you get to the modifiers by going over to this right-hand box down here. And there's a ton of different settings that we will touch on in due course. But if you go down to this spanner one, add modifier, okay, you can choose a bunch of different modifiers, and we're going to choose Boolean. And there's different types of Boolean. We're interested in the difference one, subtract. So we're taking this one on the left, which we've applied the Boolean to, and we're going to subtract a different object. So if we now use the eyedropper and we select this object, then it's subtracted it from it to produce this kind of Death Star shape, which is really apparent if we hide this one. So if we go up to here on the top right of the whole screen, not just the 3D viewport, we have a list of all the things in the scene, and we can see the one that we've currently got selected as it's highlighted a little bit in orange. If we make that invisible, then we can now see that we've created this kind of Death Star effect by having a set of two spheres and subtracting one from the other using a Boolean operator. So right now, I haven't clicked apply, and it means that I could take this sphere and I could actually move it around, and the Boolean operator is still kind of updating itself, even whilst I'm moving its, its component pieces. So you don't have to click apply, but obviously with both of them visible right now, it's not that impressive. However, if we turn off one of them, i.e. the one that we're subtracting with, if we make that invisible using this eye icon up here in the list of all the objects, then I think the effect of what we've done is a lot more obvious. But you don't have to apply it initially. You can just have it there, as I've done right now. It's not been applied, so that means it's still, in effect, it's still editable. But if we were totally happy and we wanted to simplify things, then we could click the apply button, like I'm just about to do. And now we have this Death Star shape, and that's not changeable now. If I turn the subtracting sphere back on like that, and I move it around now, we see that it's not eating any extra into the original one. Now, to make something a bit more complex than that, I want us to use an asset store for this part. So quite often with 3D modeling, even if you've made one part that is entirely original, you would still place pre-made objects that other people have made and that you've purchased or you got them for free. You'd still place those around it in order to reduce the amount of time that you spend making every tiny little detail. So normally, 3D work is about a combination of original things and then pre-made things, and that's fine. People put them up there so that they can be used. So what I'd like us to work with for the rest of this tutorial, we're going to build this model of a robot hand that I mentioned earlier on. So if there's a bunch of different repositories online that you can get 3D meshes from, Thingiverse is a good one. That's kind of used mostly by the 3D printing community. So it's objects that have been designed to be printed off and then normally assembled afterwards, like this arm, this hand. You print it in lots of different pieces, and then they all slot together, and you have a functional robot hand. So that's Thingiverse. There's also Sketchfab. That one seems to be popular for 3D scans. So you take a 3D scan, have your point cloud or a mesh, upload it to Sketchfab, and it lights it all really nicely, and it lets you kind of move it around in 3D. There's also the Unity Asset Store. That one's great if you're building your stuff within Unity, because it will already make use of Unity-specific lighting techniques and things, so you don't have to set anything up from scratch when you import it. There's TurboSquid. That one is a lot of things on there are paid. They can get quite expensive, but they're generally also of a very good quality and useful for just sort of, for instance, I've been working on a project where I've been building a virtual reality version of somebody's garage, where they want to be able to train people who are currently locked up on how to start doing vehicle maintenance. So they wanted a full VR copy of their working garage. And so I took some architectural plans and modeled that within Blender and gave it materials in the ways that I'm going to show you. But then all the little bits and bobs lying around the garage, just like bins and fire extinguishers, that kind of thing, just got them from TurboSquid in other places, and it just makes it look like there's a lot going on, but you're not having to model every single thing. If you're making a copy of this room, you'd model the windows and the floor and this interesting feature at the top, but you'd get your chairs and tables, etc., from an asset store. It'd be quite foolish not to in many cases. There's also GrabCAD. That's normally for things that have been designed in specifically CAD software, things such as SolidWorks or Rhino, which are different to overall 3D software such as Blender in many ways. And there's BlendSwap, which is Blender-specific stuff. So anyhow, if everybody that's participating wishes to get hold of the robot hand from the address here, and it's also all contained within the Google Drive folder for anybody that's already got that open. So 00 robot hand, there's also the robot hand folder that I've just opened up. You can see that. And the majority of the pieces, all the ones that we're interested in, are contained within this hand v49 ready to release. So what I'm going to do now, if you've opened the robot hand Blender file, this will already be done. But I'm going to show you, you can import it into Blender along with a lot of other different 3D file formats. So if you go up to the very top left into File, Import, and then STL, that's the format that we got here. That one's very popular on Thingiverse because, as I said, it's largely a 3D printing site, Thingiverse, and STL is sort of the de facto 3D printing file format and has been for like 30 years before anybody knew it was a thing. So if you import STL, like so, then we have to find the folder. Where was that? It was on the desktop for me. Blender tutorial robotic hand, and that was the file I mentioned, hand v49 ready to release. And then once it's selected, right up here at the top right, import STL. So import STL, here it is. Wow, it's huge. It's probably too big to work with because it's on a totally different length scale to, say, the cubes and spheres we were adding earlier on. So what I'm going to do is I'm going to just type S to scale it and 0.1 to reduce it to 10% of its original size. And now we'll find that if we add something new within Blender, it's going to be roughly a similar size. So now, if we click on it, the whole thing turns orange. And if we click away from it, the whole thing is deselected. That's because this is a single object here. So even though it's made up of a load of different parts, and you can see they're all separate, it's been imported as a single object. That does happen sometimes. And in this case, it's because they wanted us to 3D print this robot hand. So they've already laid it out for us as a single mesh, all kind of sitting on a flat bed ready for printing. But for what we're doing, we don't want to do that. With this hand selected, we're now going to separate it into a bunch of different objects rather than just have it all as a single object. So with it selected, we go into edit mode. Remember, we do that with the tab key. Hey, here we are in edit mode. And remember, if we click onto empty space, it deselects everything. If we hit the A key, it selects everything. And if we were to click on a particular bit, we would select a particular face in this case, but we could also have it on vertex mode. So with everything selected, now to separate them into different objects, if you go into the menu up at the top, to the Mesh tab in that menu, and yes, it's not the menu at the very top, it's the one at the top of our 3D viewport. And if we click Mesh, and then we go down, 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 down. Also, yeah, make sure you've got the whole thing selected. It's all highlighted in orange. So if we now go to, Mesh, down to Separate, and you see that one right near the end. And then we say by loose parts. And what it's doing here, it's kind of running across this single object here, and it's determining which ones are actually connected to which other ones. And if an object's not connected, then it becomes its own object. It's just a kind of simple mesh algorithm, one of many that Blender just has built in. So separate by loose parts. Let's click it. And now we see that there's only one object here in edit mode right now, and it's this thumb tip. So if we leave edit mode and go back into object mode, we can now see that they're all separate objects, which is great for what we want to do next. There's a bunch of different files. If you open the original robot hand.blend, 00, and then at various different stages, I've saved a different one so that you can pick up from wherever's most comfortable. So now we will see that we've got all of these separate objects. However, they are all disconnected. They've been spread apart by the designer for 3D printing. And so we're going to now manually move them all back together so we get the hand into the shape that we want. So you can select objects. Remember, you can hold Shift and click multiple objects to add to a selection. I've selected these four kind of, just above the palm of the hand. It should make some sense that here we've got the palm of the hand. These are all the components of finger 1. These are components of finger 2, 3, and 4. And these are the components of a thumb, which, as you know, behave in a slightly different way mechanically to fingers. So if we select the 4 bits of each of the fingers that are closest to the palm, and then we move them down using G, and then press the Y key, so we constrain that movement to the Y-axis. And I'm just going to eyeball this. I'm just going to move them to what appears to be into place. But there are ways to be more particular about that, like there's this magnetic snapping option that you can turn on up here. But for this, I'm going to just eyeball it. No, but you could do it with this, this magnet icon. If you turn on the magnet option, and then I'm moving things around, but they snap into place. You can either snap them to a grid, kind of absolutely, or you can snap them relative to other features. So let's move the next bunch down. I'm going to deselect everything with Alt-A, or just click into empty space. What we were doing just now is clicking them one at a time, holding the Shift key. Another really useful shortcut in Blender, if you press the B button, you're now in box select mode. And this works in object mode. It also works in edit mode. You can select vertices using the box select tool. So just press B, and now I've got this crosshair. And if I click and drag, then I draw a box, and everything that's in that box gets selected. That can save a ton of time when you're doing this kind of work. So let's box select with B. If I deselect them, well, there's another similar one. If I press C, now I've just got this kind of patch, and if I click and drag that, then maybe it doesn't work in object mode. It's very useful in edit mode, though. But yeah, let's use box select. We've selected those four, and we're just going to move them down along the y-axis like we did before. Oh yeah, I'm going to turn off that snap with the magnet up there. So move them down the y-axis into place. I think that's roughly okay for this. And then again, deselect them with Alt-A. Use the box select tool to grab the next bunch. Move them down with GY. Just eyeballing it. Are you all keeping up? Good, good, good. And then the final bits, the real tips of the fingers, the final bits of fingers at least, let's move them into place like so. So our hand is starting to take shape. The thumb's still looking a bit odd, so I'm going to do the same kind of thing as before with the thumb. So I'm going to select this bone. It is a bone, effectively. And I move that down with GY. And the next bit, I move that down with GY. And the very tip of the thumb, I move that with GY. So then we have all of these different components. They're currently not connected to the palm of the hand, but we can do that if we move it with GX. And we drag the whole thing along and put it in place. And there we have it, guys. The robot hand is fully assembled. And if we move it back into solid mode, then yeah, you can see that just like so. So let's build a wrist for this hand so you get an idea of integrating bits you've made from scratch with bits you picked up elsewhere, as I do think that that is a really essential part of doing 3D modeling. So we view it from the top. We view it from the very top using the Z button. If we add a cube, like so, maybe put it into X-ray mode again with Z. So now we have a new cube here. If we move it down, so it's kind of sitting at the base of the hand, and then we go into edit mode with tab, remember? What we can do then is start just dragging the vertices around to get it into where we want it to be. So let's move it along in X, that one, and pressing Alt-A to deselect, and using the box to select them all. And I'm moving those ones along like so. And then if I select these ones at the bottom, I can scale that along X, like that. I can move it along X with GX, and I can move it along the Y-axis with GY. So by dragging that out like so, you see how we've produced a wrist going onto the bottom of the hand now. However, if we move it along, if we move around, change our perspective, we see that it's not perfectly in place along that axis. So if we select everything with the A key, and we can get our view kind of perfectly side on by clicking the axis gimbal. Then if we type G, and we're moving up the Z axis this time, and we can move it into place like so. And there's our wrist. We could also thicken it out along the other axis if we use the box select, and we scale in Z. Just like so. So there we have our hand and a wrist to go with it. So now if we wanted to animate this, this is where we use Blender's timeline features. I want to talk about animating. I don't think we'll have time to work through all of these examples, but I want to at least demonstrate them to you. So if I wanted to animate the tip of this finger, then we use the timeline down here. If I press the play button, we can see that now we're moving through time along there. If I click at a certain point along the timeline, we go to there, and I can type in a particular frame over here. But we're not animating anything. Nothing's moving, so moving along the timeline is really boring, as nothing at all is happening. However, if we insert a keyframe, and I do that by up here in the 3D window, if I press the I key with, say, this thing selected, and I insert a keyframe there's a bunch of different properties. I'm going to just choose its location here. So that's I for inserting a keyframe. We've got that on the cheat sheet. We've now got a keyframe saying where its position is on frame number 1. So if we hit play, that's still kind of boring because it's not moving to anywhere. It's just got a keyframe saying where it is. So if we move along to some other frame, I'm currently on frame 80, and I then move the fingertip, say, along the y-axis, and I insert a keyframe on its location there, and I then were to play it from the beginning, oops, then we see, voila, the position is changing over time because of the keyframes we added. You can also move keyframes around and change the values that they map things to, that kind of thing. So this is essentially how we animate things, but I'm going to show you a demo of what happens once we've rigged a skeleton model to the robot hand. So what I've done here, I went into Add, and instead of adding a mesh, I added an armature, which is effectively a bone. And then using the same extrusion and movement and rotations and scales that we've used for mesh modeling, we've used the same things to be able to construct this armature, this skeleton. And then you can hook each component of our robot hand into a specific bone of the armature. And what happens then, if we go into, so instead of object mode and edit mode, if we've got an armature selected, we can also go into a third one called pose mode, which you see here, which means that now we can grab a given bone and we can move the bone around. And if we were to work with a lower bone, a lower down bone, then it moves the ones above it. They move with it. So this is the benefit of working with an armature, and they're all connected together. So if we were to take the wrist bone and move that, the whole thing moves with it. If we took a fingertip and we just moved that, then there's no bone after it. So I select a bone, and then I press G, and now it's moving. And remember, we can left-click to confirm and add it, or we could right-click to release it. So that's working with armatures and bones. However, then we want to be able to make these things behave realistically. I wanted to show you a slide of how uncanny it can be when things aren't rigged up properly and they don't behave as expected. This is from Adult Swim, and it's pretty horrifying. This kind of vibe is proving quite popular in the 3D animation world at the moment, just doing these sort of foul, mind-bending things, where things behave like they shouldn't. And so the process of doing this rigging kind of ensures that things start behaving like they should. Otherwise, if we were to just hit play, then it either wouldn't do anything, or it would probably just all turn to jelly like this, or some sort of nasty stuff could happen. So we're being careful to rig it properly. Once we've built an armature, like we have here, if I then go to the next file, which is robot hand rigged and constrained, we've now added constraints to the skeleton. And what that means is that we've manually typed in kind of how each joint ought to behave. And now, if you're freely deforming these things, they've got their limits that they won't bend beyond. So the robot hand is now starting, if we go back into pose mode, the robot hand's now actually starting to behave more like a real living system. You see, I can bend the finger one way, but it has a hard limit and it won't bend the other way. And I've done that to all of the different joints within the robot hand. So this is another part of rigging. You've built your rig, your armature. You've hooked it into your object. So the armature now dictates how the object moves around. And you then impose constraints on the joints so it starts to behave in a more realistic way, or just a more interesting way if you're not going for realism. So that's constraints. The penultimate thing that I want to show you is called inverse kinematics, and this is where animation starts to get really fun. So once we've built our rig, we've constrained the joints, we can then tell each joint to have inverse kinematics on it. And we can say for each bone that has it, how many previous bones its inverse kinematics affects. And what that means, if I grab this fingertip and I start to move it around, can you see that? That all of the adjacent bones now move with it in order to bring the tip to that desired endpoint. And this cuts out so much manual work. You're now not moving each bone individually. You're just kind of moving the ones at the very edge. And they affect all of the ones lower down the chain up to a certain point. And similarly with the thumb, that's got a different kind of mechanic to it. But we're still using these inverse kinematics. The really cool thing about that is that we can add keyframes, as we were doing earlier on, to the position of bones within the armature. So if I were to take that particular bone and give it a keyframe on its location, rotation, and scale, because I'm not sure what's going to be the most influential there. And then I went to a different frame, and I moved it around to a different position, and gave it another keyframe. You should find that it now animates like so. I'm not sure why just the tip moved there, actually. It should have done more. So I'm going to open the final file now where I've rigged the hand, I've applied constraints to it so they move realistically within limits. I've applied inverse kinematics so that just moving the endpoint affects the entire mechanical chain leading up to it. And then I've used keyframes to save a bunch of different movements and poses. And so now we get this hand that moves through a range of different poses, like so. And we can put that into render mode, and we can give it a nice metallic material, but I don't think we'll have time for that. A final thing, so we've made it do some cool things within Blender, but we're talking about augmented reality here, so we want to get it into Unity to then compile into an app, for example. Now, to do that, there is a format that I find to be particularly nice for moving complex things between softwares, and that's the FBX format. So if we selected everything, and we went down to File in the top left of the whole window, not just your 3D viewport, and we go to Export and FBX. And then we can export not only the robot hand, but also the skeleton model, the relations between that and the meshes, the animation keyframes, even the material properties, even things like lights within the scene around it. You can export all of those as a single FBX file, which you can then import into Unity and be able to play it back perfectly, I've found. So FBX is the big takeaway for that one. You know, once you're animating things, you can save it all in that format and then move it over into Unity. Because Jazz has had some success animating things for the Leonardo project in Unity, but I've found that it's just not as well designed for animating things as say, Blender or other things such as Maya or Cinema 4D. If you went with any of those other softwares, FBX is still kind of a very good go-between format. And if you did choose to go with one of those other softwares, I think that a lot of the fundamentals that we've just covered, such as how to manipulate things in 3D software, how to play with vertices and edges and faces, the Boolean operators, you can do so much with those things, and the concepts of animating using keyframes and a timeline, and the concepts of rigging things with a skeleton, they are universal. So I've shown you all what's possible with that within Blender, but if you happen to find yourself in a job, say, that says we need Cinema 4D, it would carry over very nicely, I think. Yeah, it would save an awful lot of... You'd just be learning like new keyboard shortcuts, effectively. And maybe not even that for some things. So I hope that you've all kept up along with this. I know that it is a lot to take in. Blender is just incredibly versatile in what it can do. It's a very, very powerful piece of software, and trying to capture that, what it's capable of, within just an hour and a half is tricky. So I'm sorry if it's gone too fast or been confusing at any points. But I do hope that you've all learned a few things along the way and felt inspired to build your own things with 3D software, because I do think it's a really essential component of working with augmented reality. Whatever aspect of it you choose to work with, you'll work with people that do 3D work. So just knowing what goes on in their processes is undoubtedly going to make you a much better colleague for that kind of thing. So thank you very much.